Okay, everybody, welcome to this session of the Protect Our Water Conference. Today we're talking about erosion control. The part of the stormwater management program does have a permanent erosion control program. So this is a little bit of a deviation from construction BMPs in that the erosion control projects that we work on are meant to be permanent. But part of that process of installing these permanent erosion control projects is, of course, temporary BMPs. And also, there's a lot of the contractors' involvement in the long-term maintenance and plant establishment periods during the first year of plant establishment. And so we just wanted to give you a little bit of a background and information on what we're up to in the permanent erosion control program. So my name is John, by the way. I'm a consultant for Enviro Services and Training Center. And I've been helping manage the erosion control program since 2013. And Jason and Mark, who you'll be hearing from momentarily, have also been on the team, I think longer than I have. And Jason works for Olympiaco Consulting Group. He's worked there for 21 years. He's a licensed engineer in civil design. And Mark is a landscape architect with PBR Hawaii. So I'm going to let them hand it over to Jason to start with to kick off his presentation.
All right, thanks, John. Welcome to our presentation. Today we're going to talk about some lessons learned for DOT slope improvements for erosion control. I'm Jason Lau. My partner for today is Marc Shimatsu. The DOT Highways Division, as John mentioned, they own and operate a municipal separate storm sewer system, otherwise known as an MS4 on the island of Oahu. Now, the MS4 permit identifies water quality requirements for stormwater and non-stormwater runoff. And a stormwater management program was prepared as a guide to assist DOT in meeting these MS4 permit requirements. And one requirement of the stormwater management program is to address post-construction stormwater management in new development and redevelopment, which is essentially permanent BMPs to minimize stormwater quality impacts to the maximum extent practicable. So some examples of permanent BMPs that have been constructed for DOT include.
Are we supposed to see your PowerPoint right now? Are you sharing your screen?
Should be. Can you see it?
I'm not seeing it. Maybe you have to switch screens.
Hold on. Let me try that again. How's that? Can you see that now?
No. There should be a way to swap screens. I think you're sharing your video. There we go. Got it.
Okay. Can you see that now?
Yes.
Okay,
thank you.
That.
Yeah.
Okay. Let me rewind a little bit. So some of the permanent BMPs to help minimize, or some of the permanent BMPs that have been constructed for DOT include some outflow repairs, some trash and sediment capture devices, such as these catch basin filters and baffle boxes. There have been some bioswales that were constructed, and also slope improvements, which is what we'll be focusing on today. So as you drive around the island, you may notice some eroded sites. And these are just caused by erosion, which is wind and rain, and over time, the top layer of nutrients wash away, and you're left with a situation that's difficult to sustain any type of plant growth. And as the sediment washes away, you can see most of the roads are located next to a gutter or a ditch, and the sediment ends up in the MS4 system. And as a designer, we prefer to address the erosion on the slope rather than trying to catch the sediment downstream. It's typically more effective and also less costly. So there's several factors that are considered when determining which slopes to address, as well as the type of improvement to implement. And some of these include the watershed location, slope location, slope gradient, the soil type, and naturally the cost. So Enviro Services helps DOT to manage their NS4 system, and they evaluate and prioritize watersheds based on the total maximum daily loads, which are set by EPA, and also the required waste load allocation reductions. So the watersheds that require the highest reductions typically have the higher priority. So you could have, basically you could have two slopes that have the same erosion rate, but the slope that's located in a more sensitive watershed will typically be addressed sooner. Implementation and monitoring plans are prepared for specific watersheds, and these plans determine how much reduction is required. They also estimate theoretical pollutant removal rates based on certain BMPs, and then we get involved by taking the planning ideas and transferring it into the design as we prepare the plans and specifications. So for each slope, where is the slope located? Is it located next to a busy highway? How much room do you have for construction vehicles and for equipment? And is it safe for the workers and for the public? Safety is always the primary concern. So for this slope, this is in Kailua. It's roughly 40 to 50 feet tall. So if you can imagine if a rock falls from the top of the slope, what could happen there? All of these we have to take into consideration. So do we need to close off one lane during construction or two lanes? Or do we need to do the work only at night? So all of these are factored in terms of what type of solution to do and it also affects the overall cost of the project as well. And is the site located beneath an overpass? And is there adequate sun and water to support vegetation? If you look at, there's a stark distinction between a covered and an uncovered site. And if vegetation cannot grow, we'll need to look at considering other types of armoring techniques, which will be discussed later. Slope gradient and soil types are also factors to consider. And steeper slopes don't necessarily mean that more erosion will occur. Some soils can withstand steeper slopes, such as this slope on the right-hand side. This is in Kailua as well. And if you look on the bottom, there's not much sediment that leaves the slope. So for each of the sites, we do work with our geotechnical engineer, and they help us to identify the recommendations for our design. So some of the BMPs that have been used for slope improvements include slope grading, erosion control matting, grouted rip rap, articulated concrete blocks, concrete fabric, and also vegetation, which Mark will cover later. Slope grading is essentially just grading back the slope. Obviously, if you grade it flat, you would eliminate erosion, but this is going to be very costly to remove all of excavated fill or excavated quantities of dirt. Whenever you have trees, that's also an additional cost you need to consider. And typically for DOT right-of-ways, the right-of-way is typically right at the top of the slope or a little bit beyond the top of slope. So a lot of times there's not that much room to grade it back. In this situation here, we definitely want to address these overhanging conditions, which may be a dangerous situation for motorists. But it gets tricky when there is trees, or in this case, roots. Often they help to hold up the slope. So in these situations, we'll defer to our landscape architect, and they'll determine whether to keep the tree or remove it based on the health of the tree and also other safety concerns. The most common BMP that we've used for slope improvements is erosion control matting, also known as turf reinforcement matting or road erosion control products. And the rule of thumb is generally if the slope is steeper than 3:1, we'll use some type of matting. If it's less than 3:1, we can address it just with grassing or hydroseeding. These come in rolls that you generally install from the top down. You just roll it down the slope and you shingle it so you have overlapping coverage. And the intent for the matting is to protect the slope, you want to prevent runoff from running down the slope face, and also to help promote the vegetation. And there's numerous types of matting available. This is one that we've used. I call it a medium duty matting. It's a permanent matting that has a coconut fiber, and the coconut fiber helps to retain moisture and promote plant growth. The coconut fiber is sandwiched between two layers of UV stabilized polypropylene netting, which help to hold it in place. And generally, these are found to be successful in the products that we've used it on. For steeper slopes that are greater than 1:1, we'll go with a more heavy-duty matting. This particular one is woven out of polypropylene fibers, and it has a higher tensile strength. And if you look at the profile, it has, pockets on there, and they generally help to capture sediment from the slope, and that also helps for plants to grow. Then situations that we have maybe in more wetter areas that vegetation can grow more easily, we'll use a more temporary matting, such as this one. This one also has a mesh that it helps to retain moisture for plants. And these generally biodegrade in about 2 to 3 years. And in that time, the grass should be well established enough to prevent erosion from occurring on the slopes. A typical erosion control matting system looks like this. If you notice the top and bottom, there are trenches, and these help to lock the matting in place. The top trench is very critical as well because it also helps to prevent migration of water from going underneath the matting. So that prevents erosion from the slope. The bottom trench is shown, that also helps to lock in the matting. And generally they're just trenches 1 foot or 2 feet wide, and they're backfilled, and then it's wrapped around and pinned down to be secure. What's also important is to have anchoring devices along the face of the slope. And this is very important because you want to have a good contact between the matting and the ground. And the anchor spacing is generally determined by either the geotechnical engineer or the manufacturer, and they're based on the slope height, the gradient, as well as the soil type. And like I said, you want to have that good contact with the ground. Situations like this, you shouldn't have any wrinkles or tinting. And what we've learned is that when you do have tenting such as this, it doesn't allow for the grass to grow in very well because by the time it reaches the matting, the leaves on the grass are big, and it prevents them from popping up through the matting. So it ends up pushing the matting up even further. And then once you do have that tenting or wrinkles, any water that gets below the slope, gets below the matting, can travel along the slope and cause erosion. So it's very important to get a good contact between the matting and the ground. And this is generally done with anchor devices. These are several that are available. We have steel pins and staples. We have some stakes on the right-hand side. There's a wooden stake shown next to some biodegradable stakes. And the bottom photo is of an earth anchor, commonly known as a platypus anchor or duckbill anchors. And these are used for slopes in which you need a higher tensile strength to secure the matting to the slope. So all of these are, you can choose different lengths depending on the depths that you want to secure the matting. Some lessons learned in terms of the anchoring devices. The steel pins and staples, they do corrode easily. For the pins, we've heard of stories where maintenance workers have walked on the slope and the pin is left in the ground, eroded enough or corroded enough where it penetrates their shoe. So we try not to use this in a situation where people may be walking on the slope. We've tried some wooden stakes, which is in the middle, and we found that in some areas, termites just love these. From the time the contractor installed the matting and the stakes to the final inspection, which were several months later, we found that all of the stakes that were buried below the ground were completely gone, just eaten by termites. So after we used these, we tried using these biodegradable stakes. And these have generally been pretty good. We've had good results with these. They start to degrade after 2 years. They're made out of biodegradable plastic. So these have fairly been pretty successful. Another lesson learned we use from using these earth anchors on the top right, as you pull the cable to, initiate the tension, you're left with this dangling cable at the top of the surface. And we found that as maintenance workers go in with their weed whackers, a lot of times it can get tangled with these cables. So we've now cut them to maybe about an inch to within the slope, and then we'll cap them with a little plastic cap to prevent it from fraying. So in areas where plants can't grow, such as beneath overpasses, we need to look at armoring systems such as articulated concrete blocks. These are typically limited to slopes no steeper than 1.5 to 1. And these individual blocks are interlocked together to form a system. The spaces between the blocks, they can be left empty, such as this one, or you can also fill it with gravel or concrete when it's not necessary. What's important to note is that site preparation is important. You want to have that subgrade pretty level because the top surface is going to reflect whatever's down below. The blocks are available in different shapes, and they're interlocked together. You can also get them cabled together as a system, which can help with making installation a lot faster and easier. The blocks are typically anywhere from 4,000 to 6,000 psi compressive strength, and they're relatively lightweight, between 30 and 50 pounds. So you don't really need a lot of heavy equipment to install them. You can have a crew that just manually places them along the slope. And another good thing about these is that they can be cast locally. At Taoko, they do have a dry cast machine, so they can help to keep your costs down. Typically, they're installed along the slope. You have the openings allow for surface water to filtrate through. And then you have a filter fabric down below, which helps to increase the friction to prevent sliding. This next slide is one of our sites out in Waikele. As I mentioned, the interlocking blocks, they act as a single unit. So you have to look at the total weight of the system and as it bears down upon the bottom edge. So in this case, we had an existing sidewalk that we could use for support. If you don't have an existing sidewalk or a curb, then you can also bury the bottom layers, or you can construct a concrete header curb for support. Initially, we used to place gravel around each concrete column. And our thought was to fill in that void. We don't want to have rubbish and debris accumulating in these pockets. So we would have gravel in there. But later on, we found that the gravel would migrate and become a slipping hazard on the sidewalk. So we then filled these with grout. And the grout itself would have a lower compressive strength so that if the sliding of the blocks do start to push up against the columns, at least the grout would break first before it does any damage to these columns. Similar to the articulated concrete blocks, we've also used Grouted Rip Rap in areas beneath overpasses. These can typically go up to a 1-to-1 slope. And the thickness of these vary anywhere from 12 inches along the slope face up to 2 feet thick at the top of slope. And it creates an impervious surface, so you have to consider any runoff from other areas. Because it is a monolithic structure, the total weight of this also needs to be considered, and we usually have our structural designer design a thickened edge along the bottom, and that helps to provide support and prevent sliding. So here's a difficult site that we were addressing. We have a lot of rills and gullies. These are from some weep holes that are located, from the overpass above. And here's the after photo. And so maintenance of the Grouted Rip Rap is pretty maintenance free and it's pretty durable. And some of the repairs that you may have to be faced with is just to touch up some patching made from cracks that show up over time. Another product that we tried is this concrete fabric, and it's similar to erosion control matting, except this one is impregnated with cement. And we chose to use this at this outfall location. We had high velocities from this outlet pipe, and the soils in this area were very erosive. If you were to step on this dirt on the side, your foot would just sink in a few inches. And as you can see, there's heavy overgrowth, so we can't vegetate this site at all either. So we chose this concrete fabric. It's installed using pins. And once it's in place, the contractor then shoots water over it, and the water initiates the curing process. And over a course of a few hours, it starts to harden and turns into a concrete surface. And so one thing I'd like to know too is that DOT is very open to trying different erosion control methods, which makes it exciting. We have to look at what's out there, what's been used on the mainland. And so they're good in that they let us try things, and if it works, we'll use it for other projects. And this is generally a flow chart that I put together, kind of summarizing what I've spoken about, the steps that we use to how we address each slope. If we can grade back the slope, we'll grade it back. And depending on what the slope is, if it's 3 to 1, we can grass it or plant it using temporary matting, or sometimes if it's flat enough, we don't need matting at all. If plants cannot grow under a covered location, we'll turn to a armored technique such as Grouted Rip Rap, articulated concrete blocks, or concrete cloth. If you can provide vegetation, we'll use matting, and depending on the type of slope, that'll help you determine whether we use the heavy-duty matting or something a little less. And some general costs, these are just based on some bid tabs that we've received for several projects over the years. Naturally, these are highly variable depending on their project size and location, but just some ballpark figures for comparison purposes. Some other lessons learned. We've learned that vegetation can vary dramatically between the wet and dry seasons. Trees can grow, trees can die, erosion may improve or it may worsen. These two photos are shown along the same stretch of road. And we've had projects where we've gone out and done the initial site reconnaissance. We've done a topographic survey. And the site on the left is kind of what we've seen. We've designed the erosion control matting to cover certain project coverage. And then by the time the project goes out to bid, contractor shows up at the site, the grass has already grown back in. So, a lot can change. And so what we do is a lot of times we also have the opposite condition in which erosion may have gotten worse. So we've included some force account items to allow for some flexibility during construction. Another lesson learned involves topographic survey. Initially, we used to just use as-built drawings as our basis of design, especially for projects that involve articulated concrete blocks or matting. The installation of those are relatively straightforward. So we will do our site visit, we do our measurements. In the case for the concrete blocks, if the blocks are 6 inches thick, we call out for 6 inches of dirt to be removed, place the blocks in place, and then basically you're going to match existing ground. But what we found over time is that a lot of times RFIs will pop up during construction. Either the dimensions are off by a few feet, or the areas are off by a few square feet. So, in the long run, the RFIs do cost money. So we just decided just to do the topographic survey to get more accurate results, accurate design, and less chance of RFIs during construction. Eucalyptus trees. We've also found that for some reason, there's something in the trees or the leaves in their sap that makes it very difficult for other plants to grow beneath them. So if you see a grove of eucalyptus trees, often you see it's very bare beneath them. They also have these tiny leaves. So in this case, you can see the sediment coming off the slope. You have the leaves, and it just washes out into the drainage system. So it's a very bad combination for stormwater quality. So for this site, we ended up clearing the slope and laying this medium duty erosion control matting. And then the next step was to install this native ground cover. And so we didn't know whether the ground cover would survive under the eucalyptus trees. So the intent was that if it didn't grow, at least we'd have the matting in place to help protect the slope. But Mark will talk about other vegetative techniques. So real briefly, some case studies. This is along Kamehameha Highway, Haleiwa townbound. So you can see it was a pretty steep slope on the side. We used this heavy duty mat, planted some native ground cover. On the Mililani, this one was as well, had a little overhang. We ended up grading this back at a 1-to-1 where we could. And then we used this heavy duty matting to support the slope. Also planted some native ground cover. And then out in Mililani, we have another site here. You can see the rilling. And this slope is not very tall, maybe 2 or 3 feet tall, but just the type of soil out there. And it's open, you get a lot of wind and rain erosion. So we installed a medium duty fabric matting and also planted some native ground cover as well. Okay, so now I'll turn it over to Mark. He's going to talk about his vegetative techniques for slope improvements.
Okay, Mark. If you could try to shoot for wrapping it up in about 10-11 minutes by 10:40. Sorry, Jason didn't mute. Oh, I think are you muted? I can't hear you now.
Can you hear me now?
Oh, there you go. Yep, you're good.
Okay.
Yeah, Jason didn't leave you too much time, but
No problem.
it was very valuable information, though, Jason.
Yeah. I'll just quickly go through my slides. So thanks, Jason. Basically, why vegetation on the slope? It helps mitigate erosion. It helps stabilize loose and erosive soils, and in the long term, it provides better soil quality and soil stabilization. And how does it do this? Vegetation reduces the rainfall impact on the existing soil. It reduces runoff velocities by interrupting the runoff and creating turbulence. The root systems bind the soil and provide a structural stability in the root zone. It removes the sediment by trapping the sediment from the runoff. It increases water infiltration and percolation into the soil, which in turn improves soil health. And it also increases evapotranspiration by moving the water through the soil to the air through the plant structure. So as Jason mentioned, site location is important. And for us, the site location that we looked at, it really was what climatic zone is the site in. And although there are a lot of combinations, the types that we generally looked at were whether it was a dry location or what's considered a mesic location. And the dry locations are typically from the shoreline to the lowland areas, typically found on the leeward sides that have low annual precipitation. Areas like Waianae, the Everplains. The mesic zone is located just above this dry zone, and it does not get enough rainfall to support like a rainforest, but they don't experience long periods of drought either. And these are found typically on the windward areas, Ka'ava, Kaneohe. Even like Magasin, Wahiwa, Mililani areas would be considered like a mesic area. Hawaii's climate is very diverse, so temperature and rainfall can vary dramatically within the same climate zone. So that's something that we always have to take into consideration. The elevation and the landforms and soil orientation, Maka versus Makai, windward versus leeward also plays a big role. We also need to consider what plants are adapted to the conditions for the site, and whether the native plants being used were sourced from the climate zone that is being planted in, as opposed to like moving a plant that's grown in a windward area and planting it in a leeward area. Those types of things would have to be taken into consideration as well. Sun exposure. So like Jason mentioned, areas with no sun typically does not bode well for the plant material. So how much sun does the site typically get throughout the day? And are there vegetations or structures that cast shadows over the site? And what kind of soils are found there? So fertile topsoil is pretty rare to find within the right-of-ways. The projects are typically cut areas that expose subsoil. And this creates challenges for planting because of the poor growing conditions. So knowing the soil composition, whether it's a sandy soil, a loam, a clay, or combination of any, the pH levels of the soil, and the levels of plant nutrients in the existing soil is important to know in order to adjust these items for optimal plant growth. So we typically have the soil analyzed by a reputable laboratory that provides all of these existing conditions of the soil and kind of establishes a baseline for how to modify the soil to a suitable growing condition. And it's typically done with adding amendments. And these are considered like fertilizers, compost, pH adjusters. Another thing that the soil analysis may provide a clue to is whether there are any toxic elements in the soil. So one example is aluminum, which is a very abundant element in the soil. When it's combined with low soil pH or acidic soil, the acidity makes this aluminum soluble, and the plants are able to absorb these through their roots, and it typically kills the plant. So modifying these low soil pHs to make it less acidic can mitigate this aluminum toxicity in the plants. Access to the site for maintenance. Steep slopes create challenges for grass trimming, and shoulders present hazards for the work crews. Is water accessible? Irrigation systems are typically not installed within the DOT's right-of-ways, and it requires the contracts typically require the contractor to provide water for establishment for these plants during a 9-month period. And so the contractor typically installs a temporary irrigation system during these 9 months if access to water is available, or within a proximity where they can convey it safely to the site. But the contractor may opt for other methods if those don't work. And then lastly, of course not least, but a new consideration that was needed to be taken into account was Act 233. And this set the mandate for the use of Hawaiian plants, both native and Polynesian, introduced for all city and state projects. And Act 233 was signed by Governor Ige on July 13th. 2015, and the bill was enacted on June 30th, 2016. So what does this mean for the projects and how does it affect it? So the act requires a percentage of the total landscape area to use Hawaiian plants. And this percentage increases incrementally. So by the year 2025, 25% of the total landscape area needs to be planted with native plants. And the ultimate goal is to attain minimum 35% of the total project site to be planted with native plants by the year 2030. And so the example sites we'll be showing were all planted with native plants to comply with Act 233. So this first site is, if you can see from the photos, there's like a lot of shade cast from the H3 freeway overpass and the support columns. And so shade tolerant plant material was selected. So in this case, we used carex and uki in the shaded areas, and the full sun areas, Ili was planted. On this site, outbound towards Kunia, it's right before the Wakele Shopping Center. So basically the full sun site, we planted a'ali shrubs, where you can see here they're starting to pop up over the native ground cover, which is kowelu grass on the slopes. Pali Highway, Jason had a slide showing this site also, but heavily shaded. So again, shade tolerant carex was used for this site, and it turned out to thrive in these conditions. Outbound from Haleiwa towards Wahiwa along Kamehameha Highway. So before and after photos. So like Jason said, a lot of things can change on the site, but in this instance, there's a lot of subsoil that was exposed here. And for this site, we chose pili grass, which you can see here. This is the after photo of this same site. And in this case, the plant selection seemed to match very well with the site conditions. And these are like more photos of that same site. And for this site, this is outbound from Mililani. It's right before the YPO overpass. This site was actually grassed with Bermuda. This is like one of those sites that was in transition before Act 233 was enacted. But to try and mitigate that, we installed a'ali'i shrubs on the site as well. Another site headed out from Wheeler Army Airfield towards Mililani on Kamehameha Highway. Carex was used on this site as well to, I guess, to help with the shady conditions. What we did learn from this site, though, is that carex didn't do so well in full sun, and you can see the effects here. There's some yellowing of the plant material in the full sun areas, whereas the shaded areas are a little better. The plant condition was a little better for those shaded areas. Kowelu grass was installed on this site. This Jason actually had this site on one of his slides, where there was like a lot of rills and erosion on this 2 to 3 foot slope, and the carex actually did well on this site, and it helped to capture any sediment that was in the runoff. This is another view of that site outside of Wheeler Army Airfield that Jason showed, where you can see here the eucalyptus trees. And so this site actually, the native plant performed much better than anticipated under these eucalyptus trees. So we're still studying it to see what the long-term effects of the leaf drop will be, and how it will affect the ground cover in the long run. Another transition site where grassing was used on the slopes. But again, here we have ali shrubs, and in the back we have koaya trees, which is another native tree. And then this site is just off the freeway as you get towards the off-ramp to the UH. And the interesting, I guess, interesting thing about this site was this was a bioswale where the bioswale itself was a gravel mix. And so the challenge was finding a plant that could grow in a matrix like that. And for this, we selected Mao Akiaki, which is a clumping native grass, and it's typically found in shoreline areas. And it actually performed very well growing in the loose gravel condition with very little topsoil. So lessons learned. The biggest takeaway was the inability to till amendments into the slope to affect, I guess, a drastic change to poor soil conditions. And so what we ended up doing was applying the amendments on the surface of the slope. And we did this with the use of hydromulching geobinders. And we tried to, I guess, change the soil composition that way. The last thing I'd like to go over is some unique details.
Okay, Mark. Sorry.
Yes.
Yeah, we're actually out of time. So.
Okay, sorry. Yep. That's actually my last slide. So.
Okay. Oh, well, go ahead.
No, so this is just some details where we had to work with the geotechnical and the manufacturer to create a anchoring solution for existing plant material, and how to cut the erosion control matting on the slopes without affecting the integrity of the matting in order to plant through it for the plant material. So thank you very much.
All right, thanks, Mark. So just to wrap things up, we are at 10:45, 10:46 actually. We will stick around and answer a few questions if anyone does want to stick around for a little bit longer. We did get a few questions. I know Jason started answering some of them, but I'm just going to repeat a couple and elaborate on some of Jason's answers. First one from anonymous attendee. Why is polypropylene netting preferred? Have more natural fibers, biodegradable fibers such as jute or core been considered? So yeah, this is a good question. And this is something we do struggle with and do take into consideration. But basically polypropylene, it's basically like plastic. And so when we're choosing a matting for slope stabilization, there's a lot of things that we have to take into consideration. Our ultimate goal is to meet our permit requirement, which is to stop that slope from eroding soil into the MS4. And as much as we like to do that through plants, we do struggle sometimes to get native plants to thrive in the environment. The slope on the side of a freeway isn't really a native environment typically that these plants like to thrive in. So sometimes the plastic, the more durable matting is there in case the plants fail. So we still do have something in place providing stabilization. And that doesn't mean that we're not going to continue in the future to try to establish a plant, plants there in the future, but it does at least keep us in compliance with our permit. And then sometimes it's because the slope is steep and the matting actually provides some slope stability in addition to just stabilizing the soil to allow plants to grow. Those are a few of the reasons that you see a lot of polypropylene and plastic matting, but it is something that we are striving to do is move away from that as much as possible. And then I think the other question about feedback from maintenance crews, I think Jason answered that one okay. So I think Mark actually talked about this project. This is from Steve. What kind of vegetation was used on that project between Haleiwa and Wahiwa?
That was peely grass.
Yeah, I think that was one of your slides actually.
Yep.
And then from Anonymous, when choosing plants, do you also consider propagation of seeds to neighboring properties, in particular adjacent to agricultural properties?
Interesting question. No, we did not, I guess, take that into consideration. But the ultimate goal was to vegetate the slope. So if there's any volunteer plants that blew in, we certainly wouldn't rid them of the site.
Yeah, I think maybe the concern here was more whether our seeds might blow onto adjacent agricultural properties, but we definitely have the opposite issue. I mean, there's so many invasive and non-native plant species that thrive on the side of the highway that when we plant our native grasses or plants, we definitely struggle to keep out the invasives.
That is true.
And then let's see, only have time for about one more here. Oh, what is the native grass species planted beneath the eucalyptus trees? The grass appears to be quite, yeah. So I think you talked about that a little bit, but yeah, that was a little bit surprising that one did so well.
Yeah, that one is Carex. Carex is planted there, yeah.
Okay, well, we are out of time. We went a little long, but thank you all for joining us. And you've got about 10 minutes until your next session. And yeah, I think, I'm not sure if we can consolidate and answer these questions offline, but I'll try to find out if we can so we can get everyone's questions answered. Okay. All right, everybody, thank you for joining us. And Jason and Mark, thank you as well.
All right, thanks, John.
Thanks, John.